Only 2 students. Where are the rest of your classmates? Let's wait for a few more minutes before we start our lecture.
sir. Ít trong còn rất thấy mấy lâu sir.
Wait. Sorry, I muted myself while I was doing some other thing. Yeah, so I just unmute again. Let me repeat. Okay. So sorry. Just a minute. Let me cancel this. Hello, can you hear me now? Please respond if you can hear me. Can you hear?
Yes, sir.
So I think you have to turn on your volume now. If you can, some of you can hear me, means I think my microphone is working now. Sorry, I was muted.
Mic sensor chu kala ma se itong kan sa thei mi lo.
Ma se mi dang min thian lo me. Min thu them.
Ô sẽ thầy.
Yeng lo ni mấy thế ni tu nghe tu bер nghe lom zo lo nghe tu nghe mi problem này kha. Tu na problem
Sir
rồi.
Jeff hi ning the ship.
Mo Jeff mo problem này. Jeff kha it join na khai ni speaker khai mo unmute mon leo mute mon leo speaker. Mi dang min thu thei sia.
Sir mic sensor chu kal itong ala se thei lo.
Mi dang chung i frame loco Jeff. Mi dang khát thu lo soi sin teu le.
Jeff trong người sẽ thầy em đắng.
Lo soi teu mi dang khan trong lo teu.
Sir sẽ thầy lâu nhiều.
Jeff ấy problem này nè. Buổi thao về tuần lecture cho tôi rồi. Okay, I think he can hear us. Okay, I think he can hear us now. Okay. So a problem on my end and a problem on Jeff's also. So we can start again from the beginning. So I don't think I can cover much in this class because I have a meeting at 2 p.m. Anyway, let us see. What I expect you is to have a pen and paper ready with you, because we are going to trace out the output signal for this input. And in op-amp, as we discussed before, so let me start from the beginning. Op-amp, we have inverting input and non-inverting input. The voltage at inverting input is called V2. The voltage at non-inverting input is denoted as V1. And output is taken from pin number 6, and the output voltage is denoted as V0. And op-amp has a difference voltage amplifier, as we discussed before. The relation between the output and the input is that V0 output voltage is equal to gain, open loop gain. Sometimes we denote it with subscript OL, AOL here. A subscript AOL, A subscript OL. OL means open loop gain, multiplied with VD. What is VD? VD is simply difference voltage, V1 minus V2. The voltage V1 minus the voltage V2. This is called VD. And AOL, open loop gain, means without the gain of your amplifier without any feedback. Gain without feedback is called open loop gain. Okay. So even if it is denoted with, even if subscript OL is not written, like in the earlier discussion, it is still open loop gain. Open loop gain means you are not connecting the output to input, right? Suppose through certain circuit, if you connect output signal from pin number 6 or your V0 here again to V in the input signal here, then that gives you your circuit with feedback. So it feeds back a certain portion of your output voltage to your input signal. So that is called closed loop. Closed loop means you're connecting output to input. All right, closed loop. So the gain of an amplifier under such configuration, when you connect output to input, that is, you can supply part of your output signal to input signal, then that gain of such op-amp is called closed loop gain. Now, when you are not connecting output to input, the gain is called open loop gain, or AOL, right? So for standard IC 741, your AOL is 200,000. I think we have discussed this because I want to repeat it once again. I want every one of you to be very clear of this idea here. Now, for ideal op-amp, open loop gain is infinity. Now, another thing is that to part identification number 7, you are supplying plus 15 volt. Part identification number 4, you are supplying minus 15 volt. This DC supply, they are the voltage signal used for biasing your transistors. So at the very first class, I have shown you like the internal circuit of this op-amp. It consists of, I think, around 22 transistors. So in order to operate those transistors, you need to forward bias emitter base junction, reverse bias collector base junction. So for turning on the transistors, you are supplying this DC power, DC signal plus 15 and minus 15 volt. Depending on the resistor connection and all those things, it gives the proper biasing to the transistors within op-amp. And if you look at this equation here, and also that the gain here is very high. So if V1 is greater than V2, if V1 is greater than V2, then that means VD is positive. When VD is positive, let's say even if it's a very small value, 0.01 volt. Now, if you multiply according to this equation, if you multiply with the open loop gain of 200,000, it will, the output signal will tend to go to a very high voltage value. But as a device, you cannot generate electrical power out of nothing. It has to follow law of conservation of energy, right? So the electrical signal you're giving here, the positive signal giving here is plus 15 volt, means output voltage cannot go beyond plus 15 volt. If output voltage cannot go beyond plus 15 volt, VD is positive, means according to this equation, if VD is positive, certain positive value, even if such a small voltage like 0.01, if you put as a VD here, if you multiply with open loop gain, V naught will go to positive saturation value, positive voltage saturation value, which is slightly less than plus 15 volt. Okay. Now, another case is V1 is less than V2. Then that will give you your VD as negative. Difference voltage is negative, means let's say small negative value like 0.001 volt also. If you multiply with open loop gain according to this equation, output voltage will tend to go to very large negative value. But it cannot go beyond minus 15 volt. So it will saturate at a certain value which is slightly less than minus 15 volt. So which we denote it here like minus of V sat here. So output voltage will jump to positive saturation or negative saturation depending on whether the difference voltage VD is positive or negative, isn't it? So in this open loop configuration, either VD is positive or negative, it will drive the output voltage into either positive Vsat or negative Vsat. So you cannot have any voltage in between positive Vsat and negative Vsat, because even for a very small difference voltage of the difference between V1 and V2, even if it's very, very small, 0.01 or 0.001 or even 0.0001, because of this large open loop gain, it will either go into positive saturation or negative saturation, right? So in this problem, in this simple circuit shown here, you see that the voltage at non-inverting, which we denoted as V1, is connected to ground. This is a ground connection. Whenever you have a triangle like this, means this is a ground connection. This is a 0 volt. So your V1 is 0 volt. All right. And here, yeah, the voltage at inverting terminal, which we call it V2 here. V2 is now connected to Vin, input signal. Input signal is connected to this V2, the voltage at inverting terminal. So now if you look at this, V1 is 0 here. Okay, V1 is 0 volt. V2 is Vin. All right. So depending on the Vin value, it will either go into positive or negative saturation. So it's like the equation is now like your V naught is equal to 200,000 into V1 is 0 volt minus V2 is your Vin. Yeah. So if you have, if Vin is positive, Vin is positive means this is your VD, isn't it? Your VD will be, VD is negative. All right. Now if your Vin is negative, Vin is negative means minus of certain negative voltage will result in positive value. That means your VD is positive. You agree with me? So if you have an input signal Vin which is positive minus of certain positive voltage, it will result in VD, your difference voltage, which is this 0 volt minus Vin, right? So this is your difference voltage. So your difference voltage is now negative. So difference voltage negative means it will drive the output into negative saturation. You agree with me? If Vin is negative, input signal is negative, then there is a minus here. Minus of minus, it will become positive voltage. So your VD will become positive. If your VD is positive, your output voltage will go to positive saturation. All right. So I hope you understand the point we discuss here. So if you are going to trace the output signal like this, let's say this is your V naught output you're going to plot here. So let me put a dotted line like this. Let me put a dotted line like this. Okay. Now, in this interval that is between this and this, between this and this, in this interval, okay, yeah, here I have indicated the interval here. In this interval, V naught value, what will be the V naught value? Will it go to positive saturation or negative saturation? Someone respond, please, from what we have discussed. Look at the picture. Tell me what will be the V naught value between this interval. Come on, respond, please.
So it might be from the positive side, sir.
See again, here I'm telling you here, your VD is V1 minus V2, isn't it? Your V1 value is, see, according to this connection, V1 is connected to ground, 0 volt, V1 is 0. All right. Your V2 is equal to your Vin, isn't it? Vin is connected to V2. Now, between this interval, tell me whether VD is positive voltage or negative voltage. VD will be positive or negative, according to this equation.
So then it would be negative, sir.
Yes, VD is negative, isn't it? So between this interval, if you look at this, this is 0 here. Between this interval, your V in value is positive, isn't it? V in value is positive between this interval. If V in value is above 0 volt, means V in value is positive. If Vin is positive, then your Vd, if you look at this expression here, Vd is equal to 0 volt minus Vin, right? Your Vd will be negative. See, if Vin is positive, your Vd is negative. Then it will go to negative saturation. You understand this line that I discussed here? So between this interval, it will go to negative saturation like this, minus of negative V sat. Your signal will go to negative saturation, output signal will go to negative saturation. Now, if you look at the next interval here, between this interval, your V in value is tracing like this. That is, between this interval, your V in is less than 0 volt, right? So between this interval, V in is negative. You agree with me? Your input voltage is negative here. If your input voltage is negative here, there is already a minus sign. Minus into minus is plus. So your VD will be positive. V in is negative means VD is positive. If your VD is positive, output voltage will go to positive saturation. So between this interval, let's say the positive saturation value is somewhere here, plus V sat. So it will go to positive saturation like this. You understand my point here? So again, in this interval, your V in is like this. Your V in signal is like this, which is greater than 0 volt means this is a positive signal. If V in is positive, if you look at this equation here, VD is equal to V1 minus V2. V1 is 0 volt, V2 is your V in. So if V in is positive, your difference voltage will be negative value, negative voltage, and your output will go to negative saturation like this. And subsequently, in this interval, it will go to positive saturation, negative saturation. So output will be a square wave like this. You understand this point, right? Now, so let us see this input signal here. Here, this is your V1 again. Voltage at non-inverting terminal is denoted as V1. Voltage at inverting terminal is denoted as V2. V1 is again connected to 0 volt. This triangle means 0 volt is a symbol. V1 is 0 volt. Your V2 is equal to V in, right? Your input signal is again connected to inverting signal. So your difference voltage is equal to V1 minus V2, which is 0 volt minus V in. Okay. And your output voltage is equal to open loop gain into your difference voltage. So depending on whether VD is positive or negative, it will either go into positive VSAT or negative VSAT, your output signal. So please try to trace this output now. Let me put something like this. So you draw like the way I draw here. As I told you, have your pen and paper ready with you. So trace your output signal like this. Have your pen and paper ready and try to trace it. Okay, so for this noisy arbitrary input signal, okay. Now, what will be the voltage signal between this interval, the output signal between this interval? Can you predict now? Give your response here. Can you predict now? If you suppose your input signal is this kind of noisy pattern here in this interval, what will be your output signal? Come on, think and respond here.
Negative.
So it will be from negative, but I think it won't be a square wave, sir.
See, it is still a square wave. The reason is that, see, even if the difference voltage is, even if like at this point, for example, let's say this is your plus 2 volt, let's say, for example, let's say this is your just for an example, let's say this is your plus 1.5 volt, let's say this is your plus 4 volt, just for an example, right? So let's say it is like that. So at this point, plus 2 volt. Now if you look at this equation, V naught is equal to, open loop gain is a large quantity like 200,000, isn't it? Your VD is, V1 is 0 volt minus your V in is, at this point, it is plus 2 volt. Okay. So even if it is plus 2 volt, it will be minus 2 here. That means your VD is, difference voltage is minus 2 volt, isn't it? So difference voltage is minus 2 volt. If you multiply minus 2 volt with this 200,000, then what you get here is minus of 400,000. So output voltage will tend to go to minus of 400,000. But as I said from the beginning, your DC power given here to this op-amp is plus 15 volt and minus 15 volt. You cannot exceed that voltage. So instead of going to minus 400 volt, output voltage will go to negative V saturation. All right. Now, if you look at this, at this point, it is, let's say, 1.5 volt. Even if that is 1.5 volt, your output voltage will be 200,000 into 0 minus 1.5 volt. So as you see, 0 minus 1.5 volt is 200,000 into minus of 1.5 volt. So minus of, see, the difference voltage is a certain negative value. Difference voltage negative value means it will go to negative saturation again, because even if you multiply it with like this, 15 into 2 is 30, right? So it is 3 0 0 0 0 0 like this. It will go to negative 300,000, but it cannot exceed minus 15 volt. So V naught will again saturate to minus of certain saturation voltage, which is less than minus of 15 volt. And if you look at this peak also, even if you look at this peak also, this is plus 4 volt, isn't it? So your output voltage, if you calculate, it will be 200,000 into 0 minus plus 4 volt. So your difference voltage is again minus 4 volt, isn't it? So this will be 4 into 2 is 800,000 volt minus complete minus. So output voltage will tend to go to minus 800,000 volt. But the voltage signal given here is minus 15 volt. It will not go beyond that. So here also the output will saturate to negative V set. You understand my point? So because of the large open loop gain of 200,000, as long as your VD is negative, difference voltage is negative, it will go to negative saturation. It will still be a square wave like this, negative V set. Between this interval, input signal is negative. So negative input signal, it will be positive. Negative of negative is positive. So within this interval, your VD will be positive. As long as VD is positive, because of this large open loop gain of 200,000, it will go to positive saturation. Okay. Positive V set, slightly less than plus 15 volt. So it will be either negative saturated V set or positive V set like this. It will still be a square wave. I hope you get the point here.
Yes,
So I need to go for a meeting, and also I need to start my lecture. Sorry, practical class. I have to stop. I could not cover much today because of that audio signal issue. We'll have another class again. So please think about what we discussed, the operation of this op-amp in open loop configuration. Op-amp in open loop configuration. So please enter your attendance, your roll number, and we can end this session now. Okay, bye everyone.